Hello students, Straight here again. Today we're going to be looking at section 11.3, limiting reactants. Our objectives for this section, you will need to be able to identify the limiting reactant in the chemical equation, identify the excess reactant, and calculate the amount remaining after the reaction is complete, and calculate the mass of a product when the amounts of more than one reactant are given. Review vocab, you need to know what molar mass is, mass in grams of 1 mole of any pure substance. New vocab we'll be getting to, limiting reactant, excess reactant. The main idea, a chemical reaction stops when one of the reactants is used up. So reactions will proceed until one of the reactants is used up and one is left in excess. A limited reactant limits the extent of the amount of the reaction, thereby determines the amount of product formed. So here's our definition for limiting reactant. Excess reactants are all the leftover unused reactants. So determining the limiting reactant, very important because the amount of the product formed depends on this reactant. This little example, we have three nitrogen molecules, 3 hydrogen molecules, and we form 2 ammonia molecules, plus we have a little bit of nitrogen left over. So the limiting reactant would have been hydrogen. An excess reactant would have been nitrogen. So limiting excess. So here, given this problem, an example, you got 20 or 200 grams of sulfur reacting with 100 grams of chlorine. We want to know how much sulfur dichloride is produced. So first we have to get them both in terms of moles, using their molar masses. And after we know the moles, the way the textbook will go through it, illustrated here, you can come up with a mole ratio of the two things that we have available. So then you can compare that to the actual mole ratio. So it says 1.808 moles of chlorine is available for every 1 mole of sulfur, instead of the 4 moles required by the balanced chemical equation. So chlorine is the limiting reactant. As we do some problems in class, I will show you a little different way to handle this, which I think works a little better. So once we determine what the limiting reactant is, you use that reactant to find the amount of the product, doing what we did in section 2. We found the limiting reactant. We've determined the limiting reactant, found a product form. Sometimes we'll want to figure out how much of the excess reactant reacted. So here we take our limiting reactant, convert it into moles of the excess reactant, and then change it into grams. And that's how much sulfur reacted or was needed. And if we started with 200 and we used up that much of it, Do a little subtraction and we find out how much was in excess. So, reasons we might have excess reactant. Sometimes an excess reactant might speed the reaction up. In an industry, the faster the reaction goes, the more money a company might be able to make. It may be able to drive a reaction to completion or completely use up the limiting reactant. And if many times in industry, one of the reactants may be very expensive, the other reactant's very cheap. So we want to make sure our limiting reactant is the expensive one. We don't want to have excess and waste of more expensive substance. They had a few questions here. Just make sure you can answer these. I will go through why the answer is the answer. Mass of the final product in a chemical reaction is based on what? That's this basic thing we had earlier, the amount of the limiting reactant. So the limiting reactant always determines the mass of the final product. Excess reactant in this, if we start with 50 grams of each reactant. So here we would have to change both of them to moles. We'd change 50 grams of phosphorus 2 moles. We would change 50 grams of oxygen 2 moles. And then doing a little comparison, it ends up being that the phosphorus is the limiting reactant. This question, we'll do a lot of examples like this in class, so for right now, not a big deal if you don't understand it. That completes what we have for section 11.3. That in class we will do a number of problems and look at this a lot more in depth. But this is our basis for section 11.3. So that's all for now.